Bada boom. It's the smartest math student in the room. How you doing? So, me and my lovely friend Nikiyia was assigned number 64 for the trigonometry problem assigned by Mrs. Wright for our project. Now, we are to verify that these sides equal one another. First, we have 1 over 1 plus sine x plus 1 over 1 minus sine x, which is equal to the other side 2 secant squared x. Now, let's see if they're equal. Firstly, let's take a look at our denominators. We can't necessarily add these up together because since our denominators are not the same. Our denominators are not the same because the operations are different. So this is what we shall do. We should find a conjugate on both sides. The conjugate is basically the opposite of the original. The only thing that changes is your operation. So if we can do that, we can multiply, meaning they can now come together. And we can put the fractions together and have one whole fraction. Because once you do that opposite, the 1 minus, you can 1 minus sine x and put it over here, and the 1 plus sine x over here, they'll just cancel out of each other and you're left with 1 plus 1, and your denominators can now be reduced since you have an operation of multiplication and not addition anymore. So let's figure it out. First, we shall simplify our numerator. We all know 1 plus 1 is equal to 2. 1 plus sine x, that's one side, times 1 minus sine x on another side, shall get you 1 minus secant, 1 minus sine square x. So, now that we've done that, we see that this has been reduced based on our conjugate and our simplifying powers. Now, you may be asking yourself, wow, this denominator looks very familiar to what I've learned in trigonometry class. Well, you may be correct because we have a specific Pythagorean identity that gets us this. Pythagorean identities are things that can be flipped around and changed to equal one another. So one of the Pythagorean identities is 1 minus sine x squared is equal to cosine square x. That's it. You can do these and they can all equal to each other. So boom, we take that out and now it's being reduced to 2 over cosine square x. Now, does cosine square x equal to 2 secant square x? Yes, it does. And the reason why, because we also have our other type of identities that can also be used and rearranged to show what trigonometry functions are equal to each other. And when you have, now we have 2 over cosine square, which is equal to 2 secant square. And our reciprocal identity, that's the specific identity we use for this, 1 over cosine is equal to secant. So 1 over cosine is equal to secant. We're not going to move that around. 1 over cosine is equal to secant, and multiplied by 2 gives you 2 secant square x. It's the same thing if you were to multiply a regular fraction. You know, just multiply it together, numerator change, denominator change, and it's equivalent because anything you do to one side, do to the other. You do to the numerator, you do this to the denominator. So 1 over cosine is equal to secant, multiplied by 2, it gets you 2 secant square x. This proves that 2 secant square x is, in fact, equal to 1 over 1 plus sine x plus 1 over 1 minus sine x. Thank you for our YouTube. And cut.